There we go. Okay. So the only thing we didn't get to in yesterday's lesson was the tangent identities in the sum and difference group. Again, these are all in the top right corner of your formula sheet, all the ones with the U's and V's, what we're looking at here. Okay, so we're going to see how these work. For this first one, I need to find the tangent of 195. So it's already a degree for us, which is nice. We need to find two angles that add or subtract, your choice, to get to 195. So what do you like? Remember, they need to be on our unit circle. Like if I pick 190 and 5, I'm stuck because I won't be able to find the tangent of those eventually. So it's got to be unit circle numbers. No. What adds or subtracts on our unit circle to 195? That'll work? Yep. Okay. So 135 and 60. And the way I've written it, 135 will be my U, and 60 will be my V. So same as yesterday, in the formula, we want to choose the one that's addition. We're going to plug everywhere I see a U, 135, everywhere I see a V, 60. I remember with these identities, the tangent ones, the sign is the same on top, and it's different on the bottom. So the plus one has a plus on top and a minus on the bottom. The minus one has a minus on top and a plus on the bottom. That's really the only difference. Okay, so it's going to look like tangent 135 plus tangent 60 over 1 minus tangent 135 times tangent 60. And then I need to evaluate these. I'm going to do these kind of like off to the side. These are just unit circle questions. Tangent of 135. So 135 is in quadrant 2. It's my 45-degree reference angle. If I divide y over x, what do I get there? We have forgotten our units. Okay, so here's 135. It's -1. Yeah, the rad 2 over 2s. One's positive, one's negative. Divide on -1. That's one we should be able to do in our head. Okay, tangent 60. Let's write that one out. So we want the y divided by the x. Can you tell me what the y coordinate on our unit circle at 60 degrees is? Rad 3 over 2. And what's the x? A half. If I divide them, the 2's are going to cancel. And I'll be left with rad 3 over 1 or just rad 3. Okay, so I'm going to fill those in now. So -1 plus rad 3 over 1 minus -1 times rad 3. So then that's -1 plus rad 3 and 1 plus rad 3. Okay, nothing cancels here because I don't have any common factors, things that I can factor out. It almost looks like they're the same on the top and the bottom, but that 1 is negative on top, so it's not something over itself. So I just don't want to drop that and say equals 1. So this is our answer. We just need to rationalize. Remember yesterday when we rationalized, if we had a plus or minus in the denominator with our radical, we're going to multiply by a conjugate. So it's the same sign or same terms as my denominator, different sign between them. So instead of 1 plus rad 3, I'm going to use 1 minus rad 3. 1 minus rad 3. Okay. And I'm foiling on the top and on the bottom here. On the bottom, when you foil, they are conjugates. So you only have to do first and last. 1 times 1 gives me 1. Positive rad 3 times negative rad 3 just gives me -3. And then I'll deal with that in a minute. On the top, they are not conjugates. So you have to do all 4 terms. -1 times 1 for my first terms are -1. My outside terms are -1 and negative rad 3. So that's positive rad 3. My inside terms are rad 3 and 1. So another rad 3. And then my last terms are positive rad 3 and negative rad 3, which is -3. Combine my like terms. On the bottom, 1 minus 3 is just -2. On the top, -1 minus 3 is a -4. And if you have the same radical, you can add them together. I have 1 rad 3 and 1 rad 3. That gives me 2 rad 3s when I put those together. The radical doesn't change, only how many of them you have, the quantity out front. Almost done. What do you notice about every term in that fraction now? Divide both by 2. Even better, if I divided by -2, wouldn't my denominator disappear completely? Okay, so if I do -4 divided by -2, I get 2. If I divide +2 by -2, I get -1, which I won't write, rad 3. And on the bottom, -2 over -2 would just give me a 1. So this is our final answer. Remember, you can check it. You can type the problem in your calculator, type the answer in the calculator, make sure the decimals match. Okay? Any questions on that one? All right. Let's do one more of those. There's just a lot of simplifying with these. Okay, tangent 11 pi over 12. So first thing we need to do are find two angles that add or subtract to get this 11 pi over 12. So I'm going to turn it into a degree first. 11 pi over 12 times 180 over pi. My pi's will cancel. I get 165 degrees. Okay, so tangent 165. Can you give me two angles that add or subtract to 165? On my unit circle, yep. Okay, 135 and oops, there was 60. That's what I did last one. 30. Okay, that's my U. That's my V. We're using the addition identity again. So tangent 135 plus tangent 30 over 1 minus tangent 135 tangent 30. Okay, tangent 135 we already figured out in the last problem. It was -1. Tangent 30, do that off to the side here. So again, y divided by x. What's my y coordinate at 30 degrees? And my x? Okay, so in this one, I'm left with 1 over rad 3. And then that rationalizes to rad 3 over 3. Okay. All right, so let me plug those in. -1 plus rad 3 over 3. 1 minus -1 times rad 3 over 3. So I have -1 plus rad 3 over 3 and 1 plus rad 3 over 3. Okay, so we are going to have to rationalize here, but this one is the other possibility that can happen with these tangent ones is we have a fraction inside the fraction. The easiest way to get rid of that denominator that we don't want, we did this when we were doing our proofs, was to multiply by that denominator over itself. So I'm multiplying by 1. It's not going to change what it's equal to, but it's going to get rid of these kind of nasty denominators, okay? So I'm distributing it through the top. That's going to give me a -3 plus, if I do rad 3 over 3 times 3, the 3's cancel and I'm just left with rad 3. On the bottom, if I distribute it in, I'm going to have 3 plus rad 3. Yes? So what happens to rad 3 when you multiply it? So this 3, it's like a 3 over 1 times a 3 over 1. So these 3's are being multiplied in the numerator each time.
Yeah, well, like the radical at the bottom, like you multiply the denominator by the top.
So I'm multiplying this 3 through the top and this 3 through the bottom.
Like, why are you just like multiplying by 3?
Yeah, we're.
Oh, I'm choosing 3 because that's the denominator I want to get rid of.
Oh,
Is that your question?
Yeah.
Sorry, I didn't understand. Okay, so if I had like a 2 down there, then I would multiply by 2 over 2.
Oh.
Whatever, because then I want that denominator. So that's the whole point of this step. Gotcha. Okay, so now is where we want to get rid of the radical, so we use a conjugate, just like the last problem. So conjugate of that denominator. Same terms as the denominator, different sign between them. So instead of 3 plus rad 3, 3 minus rad 3, 3 minus rad 3. And again, we are foiling on the top and the bottom. If I foil on top, negative 3 times 3, negative 9. Outside terms, negative 3 times negative rad 3, positive 3 rad 3. Inside terms, rad 3 times 3, so another 3 rad 3. My last terms are rad 3 and negative rad 3, which is just negative 3. Denominator I am foiling, but they're conjugates, so outside and inside cancel. First terms, 3 and 3, 9. Last terms, positive rad 3, negative rad 3, negative 3. So on the bottom I have a 6. On the top, negative 9 minus 3 is negative 12. 3 rad 3 plus 3 rad 3s is 6 rad 3s. And then everything there is divisible by 6. So negative 2 plus 1 rad 3, or just plus rad 3, is our answer. So just like the sine and cosine ones from yesterday, you're going to get the same type of numbers over and over again. So we did 2 of these because these are the 2 things that can happen. Either your tangent is going to be just a rad 3, and then you don't have to worry about the fractions, or your tangent will be a rad 3 over 3, and you have that extra step to get rid of those fractions. Okay, so this will give you an example of each one as you do your homework. You can kind of follow along with these steps. It's the same thing over and over again. All right, any questions? Okay, last problem for today. One more proof. All right. Tangent of pi plus x equals tangent of x. So we talked about yesterday, if you see 2 angles inside a trig function, added or subtracted, you may not distribute the function through. You must use your u and v identity. And that's literally the only first step every time. Okay, so we're going to expand it. Tangent pi plus tangent x over 1 minus tangent pi tangent x. Then I look for anything I can simplify from my unit circle. Tangent of pi, I can simplify on my unit circle. What is the tangent of pi? Pi on the, what is it, the left side there, it's the y divided by the x. It is 0. 0 plus tangent x over 1 minus 0 times tangent x. What am I left with on top? 0 plus tangent x is tangent x. What am I left with on the bottom? 1. And anything divided by 1 is itself. Yep. End. You will have a problem on your homework that within the problem, you have to find tangent of pi over 2. What is the tangent of pi over 2? It is what? Undefined. Can I plug undefined into a formula? Okay. When this happens, what's another way to write tangent? Okay, or think about an identity. Yes. Sine of whatever over cosine of whatever is an alternative, okay? That's going to be your process if you see that happen. Sines and cosines are never undefined. It's going to be a bunch of 1s and 0s when you use those instead. So this will get around the undefined little barrier that you're going to hit with that one problem, okay? So when you see that happen, Go back to the problem, write with sines and cosines instead, and then you should be okay. Yes. Yes, so the original problem is not, you'll see it when you get there. The original problem is not tangent of pi over 2. Tangent of pi over 2 is just in the work. So you're going to take the original problem and write it as a sine over cosine, and then you'll be okay. Does that make sense? All right, so the rest of the period is yours today. Remember, 6-1 and 6-2 worksheets are due Friday. Tomorrow is a work day. You guys can ask me questions today. We can do problems on the board if you want to. You guys have the green binder up front if there's any one in particular you just want to check or get a hint for or whatever. Other than that, I'm done. Any questions for me? Okay, and then Friday's quiz, open note, partner over 6-1 and 6-2, the 2 lessons we've talked about so far. So you can kind of be thinking about who you want to work with for that.